So just to give you a quick tour of what's happening inside of the enclosure. So starting from the top left here, this is the computer. And so this is actually a computer from the VSLI lab. It's a full desktop computer. We have the display output currently going to the front of the cart to the touchscreen display. It has the potential for 2 Ethernet connections via the Ethernet card, as well as the motherboard's onboard Ethernet, as well as a variety of USB connections and various other things. It has a power button which is located up here, and it's plugged in via these 2 wires here. So to turn on or turn off the computer, you'll use that power button. So moving to the right of that, to the right of the power button is the Wicked issue light. So the Wicked power steering rack that's located at the front has the potential, if it gets signals that it doesn't like, to throw errors. And so this light is an indicator system from the Wicked steering rack as to what errors it's experiencing. To the right of that, we have the on-off switch for the brake and steering power. So by activating or deactivating this, you can kill or activate power to the Wicked power steering rack, as well as a brake actuator. Above that, we have the 48 volt power on switch. So this is what actually turns on the box. To the right of that, we have the relay for the emergency stop. So if you activate the emergency stop, this is the relay that trips that activates the brake actuator, as well as cuts power to the motors, so you can't drive forward. Below that, we have the Sabertooth 2X12 RC. The RC part of that is very important to remember because there's a 2X12 and a 2X12 RC, and the the switch configurations for those two are different. So this is the 2X12 RC. This is what controls the brake actuator. Below that, we have the Ethernet switch. So this is what allows us to plug in the LiDAR to the computer, as well as potentially a computer, a personal computer for SSH access or anything else into the cart's onboard network. To the left of that, we have 2 GPS units. So the first one here is a SkyTrack RTK compatible unit with a custom PCB that was developed by our phase, by Alex. And this GPS is currently functioning in Windows. However, getting RTK lib configured in Ubuntu, given it's such a new piece of software, is something that could definitely still be done. Below that is another GPS unit, and this is a combined GPS GLONASS unit. So this unit almost always has a lock. Both of these have 2 wires which go to antennas on the top of the cart. Moving down further from that, we have the PCB. So this is where the 2 microcontrollers, the 2 Arduino Duos, Duo 1 and Duo 2 are located. And so you can see one of the nice features about this PCB is that we have the headers from the Arduino. Even though the Arduinos are mounted to the back of the PCB, that we have these headers which come all the way through. So if you ever need to probe or extend the PCB, breadboard any circuits, or do anything, you have access to all of the pins on the Arduino here. On the lower half, we have the amp seal connectors.
Now the amp seal connectors are not keyed, and they're all 23-pin connectors. So make sure you put the right connector in the right slot if you ever take them out.
Correct.
Something worth noting.
And the PCB also has connections for various other things inside the box. For example, here we have the RC receiver for the remote control, and so this plugs into the PCB. We also have outputs for the power, and so you can see these go up to, moving left, the terminal block. So this terminal block is one of the terminal blocks that we have for power throughout the enclosure here. And then moving up to the left, we have a 3.3 volt supply, a 5 volt supply, and then this is the 48 volt to 12 volt power converter. On the side of the enclosure, we have fans to dissipate heat. As well as an LED strip that runs around the inside of the enclosure, which turns on when the box gets power.
So a couple other notes on the PCB. We already mentioned the green status lights for the power supplies. In addition to that, we have the sounder that can be driven by either one of the Arduinos, as well as error indication lights here, also controlled by the duets. There is already a header file in a library with macros, right, that are defined to allow you to just easily add code to turn those error lights and sounder on and off if you're developing software for the Arduinos.